Hello and welcome to this video about Pandas for data handling. We're excited to have you here, and in this video we're going to talk about Pandas operations and techniques. In this video we will talk about scaling and standardization. Scaling and standardization is about transforming features or variables into a more useful data form which we can use for a needed, usually algorithmic purpose. There is a huge number of scientific transformations with different purposes available, and in this video we will talk about some of the three most common data science and machine learning scaling and standardization techniques, which are mean corrected data, normalized or standardized data, and 0-1 unity-based normalization. All right, so what is scaling and standardization? Scaling and standardization are common concepts for variable transformations, usually but not exclusively of the linear type. There is an enormous amount of transformations advocated by various data scientists for various and any purposes. In this video, you will learn to construct mean-corrected data. This is the most common transformation, which is a computational part of many algorithms, and in particular mean parameter models such as linear regression always will include this type of transformation to calculate sums of squares, gradient descent, residuals, and similar things. And we have normalized or standardized data, which is an extension of the mean corrected data, and normalizes or standardize the data by dividing it with the feature standard deviation to create features which have a zero mean and a unit variance and standard deviation. In particular, this transformation is used in multivariable or multivariate analysis, such as prediction, in order to make different variables compete more fairly with each other so that large value variables don't dominate small value variables with only the large values as motive rather than the variable's distributional properties. And we have 0-1 unity-based normalization, which is an expression type which is very useful for some machine learning models whose transformation functions are constrained between 0 and 1. 0 and 1 is also an excellent way to interpret probabilities between 0% and 100%. In some settings and for some models, 0-1 unity-based normalization is the way to go. And we should say that mean correction doesn't affect the results of data science and machine learning algorithms, whereas standardization of the other types may affect results, speed of the algorithm, the quality of the models, the computational methods, and also regularization methods. All right, now we'll type some code and take a deeper look at these scalings and standardizations in our Jupyter Labs notebooks. So start up your code editors. All right, having started our Jupyter Labs notebooks, we are now going to type some standardization and scaling code. And we will begin by importing Pandas as PD. We will import matplotlib.pyplot as plot. We will import Seaborn as SNS. And we'll begin by loading the geyser data frame from the Seaborn library. We type geyser equals SNS load dataset geyser. And we print the data frame to make sure that everything has loaded properly. So let's run this code. And here we can see that we have a 3-column data frame. And the 2 variables we will concentrate on in this video is the duration and weighting variables, which we will standardize according to various methods. And we will begin by using the duration and weighting features or variables, and we will create 2 columns with mean corrected data. We type geyser, mean corrected duration equals geyser duration minus geyser duration mean. And we type geyser mean corrected waiting times equals geyser waiting minus geyser waiting mean. And we print the geyser data frame. So let's run this code. And here we can see that we have added 2 columns with mean corrected duration time and mean corrected waiting time. And we will look graphically at this later in this video. And now we'll continue and we will normalize the duration and weighting features or variables. We type geyser normalized duration equals within parentheses geyser duration minus geyser duration mean. Divided by geyser duration standard deviation. And we will cut and paste this code. and also calculate it for waiting times. Like this. And we will print our Geyser data frame to make sure that we typed all the code correctly. So let's run this code. And here we can see that we now have added 2 more columns to the data frame with normalized duration and waiting times. And now we will type the 0, 1 unity base normalization or min max normalization or standardization, which it is also called in some literature. We type Geyser duration equals duration minus and we divide it by duration minus duration dot min. And we will copy this code for the waiting times. We type waiting waiting and we cut and paste and we print Geyser. And we will run this code to check that our data frame has been updated with the new columns and that the calculations have been done properly. So let's run this code. And here we can see that our 01 unity-based normalization has been executed properly. And now we'll graph these scalings and normalizations with the original data to show a bit what the scaling and standardization is about. So we type fig original MC norm term theta 1 equals plots, subplots, like this. And we type geyser, plot, duration, weighting, kind equals scatter, x equals orig, and we type geyser dot plot duration, weighting, kind equals scatter, x equals mc, and we cut and paste this code. Here are one durations, and we type plot show. And this code will create 4 matplotlib subplots arranged in a 2 times 2 squares setup. So let's run this code. And here we can see that we have the original data in the first plot. And here we can see the data values on the x-axis and y-axis. And similarly, we have the mean corrected data. So we have the original mean is set to 0 and the variation remains. So here we can see that we have the mean somewhere here and that the range is about 20 and 1.5, 1.5. And we can see that we have a similar range around here. So here we can see that we just have linearly transformed this variable to a 0 mean centered position. And this is quite useful for many analyses, but normalized data is considered to be better. And here we have divided the variable with the standard deviation, which is yet another linear transformation. And the special thing here is that the standard deviation and variance are unit-based. And this means that all variables will be on the same scale after this normalization. And this is very useful for many multivariate or multivariable analyses. And here we have the 0, 1 normalization. And here we can see that all data points are between 0 and 1. And this is very useful for some machine learning algorithms, which uses transformer functions or transfer functions which have their output or input constrained between 0 and 1. And 0 and 1 is also very interesting from a probabilistic standpoint. But one must keep in mind with the 0-1 normalization that in some models, being constrained to positive values can have some special considerations. And this is in particular when you have negative variables which you force into the positive part of the value quadrants. So we can type that the library scikit-learn has a large number of pre-coded scalars for normalization or standardization functions. In the pre-processing part of the library. You can type from scikit-learn import pre-processing to be able to access these scalars. All right, now we have learned how to execute the most common and useful scaling or normalization or standardization functions using Pandas. And you have also learned some practical, useful, and fundamental theory about variable transformations and how you can use these transformations to augment and sharpen your analysis. And we look forward to see you in the next video.